Okay, so today we're going to look at trigonomic ratios. Three are the primary trigonomic ratios you're already familiar with, sine, cos, and tan. But the new three trigonomic ratios, we call these the reciprocal trigonomic ratios. Okay, these would be new. So the nice thing is you can always, these are on your formula sheet, so if you still have a copy of a formula sheet and you want them right in front of you, you can just pull that out through the lesson and moving forward in trigonometry. So cosecant is 1 over sine, secant is 1 over cosine, cotan theta is equal to 1 over tan theta. Okay, so we're just going to start by looking at our ratios using trigonometry that we learned in Math 10. All right, so I'm going to draw my x and my y here. So if I'm in quadrant, actually let's start in quadrant 1. So if I'm in quadrant 1, I know my x is going to be positive and my y is going to be positive. So we are always looking at this angle here. Okay, so that means sine theta, we know sine is opposite over hypotenuse, so it would be, opposite over hypotenuse, so it would be y over r. And because we have a positive over a positive, we'd end up with a positive. Cosine is adjacent over hypotenuse, so we'd have x over r, giving us a positive. Tan is opposite over adjacent, so we'd have y over x, giving us a positive once again. So when we move to quadrant 2, now our x is negative on that Cartesian plane in quadrant 2, but our y is still positive. So we're going to do the exact same thing. Write out our ratios. So opposite sine is opposite over hypotenuse, so it's going to be y over r once again, which is positive. Cosine is going to be adjacent over hypotenuse, which ends up being negative. Tan is opposite over adjacent, so we have y over negative x, which gives me negative. All right, now we're going to move down to quadrant 3. So in quadrant 3, our x is negative, and so is our y. Okay, so if I have, and there's my angle, if I have sine, I have opposite over hypotenuse, so I still have y over r, except for my y is negative. The r will always be positive because it's a radius, right? You can't have a negative radius. So I end up with a negative. Cosine is adjacent over hypotenuse, so I end up with a negative again. And tan is opposite over adjacent, so I end up with a positive. All right, sine. So I have a positive x this time because I'm in quadrant 4, and a negative y in quadrant 4. Okay, so with sine I have opposite, so negative y over hypotenuse, which is negative. Adjacent over hypotenuse, so x over r, which is positive. And opposite over adjacent, which is negative y over positive x, which gives me a negative. So this is going to actually lead us to our next slide here. I'm just going to kind of draw it out for you. So the nice thing is you don't have to memorize any of this. You're never going to have to reproduce it. The reason we're showing this to you is so that you can understand the castrol. So if you just memorize the castrol, then you're set. So this is the castrol. So when you're writing the castrol, you always start in quadrant, not supposed to be an S, a quadrant 4, and then kind of move your way up. So the castrol in quadrant 4, only cosine is positive. In quadrant 1, all of them are positive. In quadrant 2, only sine is positive. And in quadrant 3, only tan is positive. So the castrol is a super quick and easy way to kind of remember all this information without having to draw it all out. And there we go. You should have these in your notes as well. Okay, so now we're going to try to figure out whether each ratio is positive or negative. So sine 280. So let's draw it out and we can practice drawing those angles. So we know it's a positive angle, so we're going to start on the initial arm, go past 180, past 270 to 280, which takes me right here. So this is my angle at 280. So when we look, we're in quadrant 4. We go back to our castrol. In quadrant 4, we know sine is negative. And I'm going to draw this at the top so then I don't have to go back and forth. So we should end up with a negative ratio. So now I'm actually going to show you how to double check this using your calculator. So when you type this in your calculator, if you type sine 280 degrees, you end up getting your ratio. So let's try typing it in really quick. So the trick with this unit is you will be going back and forth from degree to radians. So in this question, our angle's in degrees, so we're going to type our angle in degrees. Okay, so we're going to go to make sure I'm in degree first. So I'll go to my mode. I'm in radians. I'm going to have to switch that to degree. Okay, and then I'll get out of here and I'll type sine 280. Notice how you have a negative 0.98. So you end up with a negative ratio. So that 0.98, that's the ratio. Okay, so you might be wondering, well, why am I doing this? Why can't I just type it in my calculator? And the reason being is actually that negative ratio, and we'll talk about this a lot later as well, there is another place on your Cartesian plane where sine is negative. So we know sine is negative in quadrant 4, but it's also negative in quadrant 3. So there's actually two angles that would give us that exact same negative ratio between 0 and 360 degrees. So there is reasons why you have to do it without the calculator, using the Castrol as well. But the calculator is super easy to double check. Okay, so we're going to look at tan now. So I have 7 pi over 6. So I know 6 over 6, right? That would be 1 pi. 7 pi over 6 would just be a little further than 1 pi. So I'm going to be over here in quadrant 3. So that would be my angle. Using the Castrol, I know that tan is positive in quadrant 3, so I should end up with a positive angle. If you wanted to type this in your calculator to double check, because your angle's in radians, you would need to be in radian mode instead of degree mode. Okay, last one here. So cosecant, we're seeing one of those reciprocal functions. So what you're going to do is cosecant is the same as 1 over sine. So we know cosecant negative 225 degrees is the same as 1 over sine negative 225 degrees. That's what that means. So that means I'm actually going to use just my sine in the Castrol. So first I'll draw the angle just like I did before. So it's a negative angle, which means I'm going to move down from that initial arm. So I'll go past 180 and my terminal arm will end in quadrant 2. There we go. So using our Castrol, we know in quadrant 2 sine is positive. So cosecant would also be positive because when you take the reciprocal of something, it doesn't change the sign. Okay, and if you're like, well, how do I type that in my calculator? Obviously, you wouldn't type this in because there is no button. You would need to type this in your calculator, and I'll show that to you really quick. Let's see, sometimes my calculator, okay, it's still in degree mode, good thing. So I would just type 1 divided by sine negative 225. And that's how I would type that in. And I end up with a positive ratio. Okay, so moving on, we're actually, we're gonna just do the first question here, okay? But I'm not gonna do all of them. So cosine, let's draw it out. And you're gonna replace acute angle, and I want you to write reference angle. So cosine, 7 pi over 4, we have to draw the angle out first. I know 8 over 4 would be 2 pi. 7 pi over 4 is just a little bit, not quite at 2 pi. So my angle is going to be right here, my terminal arm. Okay, so I'm in quadrant 4 using the Castrol. We'll draw that out again. We know in quadrant 4 that our cosine should be positive. Okay, so I'm going to write a positive here. Now you're going to find the reference angle. So the reference angle here should be pi over 4. So now what you're going to do is you're going to look and see what other quadrant is cosine positive. It's positive in quadrant 1. Okay. when I use a reference angle of pi over 4, I'd end up with a principal angle of pi over 4. So now the neat thing is if you were to type both of these in your calculator, they would actually both give you the exact same ratio, and we can do that really quickly just to show you. So because your angle's in radians, you would need to switch to radian mode. Oh dear. So I'm going to go up to radian mode. Second quit. And if I were to type cos 7 pi, where's my pi button? There it is. Over 4, enter, and then I typed cos pi over 4. Notice how I get the exact same ratio. Okay, so that's why reference angles are so helpful. And we won't do these next two. Okay, so the point -15.8 lies on the terminal arm of a rotation angle. Determine the exact values of the primary and reciprocal trigonomic ratios. So the first thing you're going to do is whenever they give you a point like this, just draw the point. Where would it be on this Cartesian plane? So I have a negative x and a positive y, which means my point is going to be in quadrant 2. So now that I've drawn my point, I'm going to turn it into a right angled triangle. Okay, so I have an x value of -15, a y value of 8, and the radius, we don't know, but we can find out, which we're going to do right now. So obviously the radius, we're going to have to use Pythagorean's theorem. So we're going to go 8 squared plus -15 squared equals, and that should give us, if we type that in our calculator, we should get 289. Okay, obviously that's not the radius. I need to square root 289 to get that radius. So I end up with a radius of 17. So now that I know my radius is 17, I'm just going to write that in there. I can write all my primary and reciprocal functions. So remember there's 6 of them. So first I'm going to start with cosine. Make sure, again, we're really picky about notation in Math 30-1. So you can't just write cosine, because that doesn't really mean anything. You need the angle. So you can represent the angle by a variable. A lot of times you'll see it represented with that theta symbol. Okay, and we're going to use adjacent, which is -15, over hypotenuse, which is 17. Okay, and of course we're always using this angle here. And then if cosine is -15 over 17, then we know the reciprocal function of cosine is secant. So that means the ratio for secant just has to be the reciprocal of that fraction, -17 over 15. Again, it doesn't matter where you put that negative. You can put it top, bottom, front, whichever. Okay, now we're going to do the next one. Let's do tan next. So tan is opposite over adjacent, so it would be 8 over -15. So the reciprocal function, and again, this is on that first slide that we looked at, the reciprocal of tan is cotan. So that means cotan theta would be the reciprocal of -8 over 15, which is -15 over 8. Great, and last one. Okay, we're going to do sine, and I'm running out of room, so I'm going to write it up here. So sine theta is opposite, which is 8 over hypotenuse, which is 17. The reciprocal ratio of sine is cosecant. Okay, and then again, I just flip that ratio. So those would be my 6 ratios there. Okay. So if the point 0.2 k lies on a circle with a center at the origin and a radius of 1, then the exact value of k can be expressed as what? So I do like this question. I drew that bigger than I wanted. Okay, the trick with k is you don't actually know where to draw it, right? Because you don't know if k is positive or negative. So you have 2 different scenarios here. You could have a positive x and a positive y, which would give you your angle in quadrant 1, or you could actually have a negative k. So if I had a positive x and a negative k, then I'd be over here, my point would be in quadrant 4. Okay, so we're going to draw these out now and write all the information we know. So we know this is 0.2, we don't know what k is, and we know the radius is 1. And then it's the same over here. So we know this is 0.2. We know our radius is 1, and we don't know k. Okay, so if we want an expression to find k, once again, this is a right triangle. So I'm going to use Pythagorean's theorem. So we have a squared, 0.2 squared, plus b squared. This time we know our hypotenuse, or c, is 1 squared. Okay, so we have 0.04 plus b squared equals 1. So b squared ends up equaling 0.96, which means b equals positive or negative square root 0.96. And we're not actually going to type that 0.96 in our calculator, because notice in the answer the radical is still there. The radical is still there, right? So it just wants the radicand, which is the 0.96. So that is our final answer. Okay, last question of the day. Given that cosecant equals 8/4, oh, and look, they tell us where the angle is, so we don't have to draw both scenarios this time. We know that the angle is between pi/2 and pi, so that means it has to be in quadrant 2 here. There's my angle in quadrant 2, okay? And they gave me the ratio. So if you know where the angle is and you know the ratio, you can find any of the 6 trigonomic ratios, right? As long as you have one, you can find any of the other ones. So just write in your information. So we know cosecant is 8/5. We also know that cosecant is the reciprocal of sine. So then that means sine is 5/8. So I'm going to use that and write it in my triangle here. So sine is opposite over hypotenuse. Okay, and I'm looking for this x value here. So to find that x value, once again, I will use Pythagorean's theorem. So I'm going to go 8 squared minus 5 squared equals x squared. Okay, type that in my calculator, I end up with x equals root 39. Because it wants an exact value, I will just leave it as that radical. I'm not going to put it in my calculator and round it to a decimal, because then it's not an exact value. It wants the tan ratio. So my tan ratio then would be opposite over adjacent, and we know that x value, the adjacent, is root 39. So that would be our final answer there. Okay, so this lesson is a pretty important one moving forward. Try some of the questions. Again, don't do all of them. You can kind of pick and choose which ones you do, and let me know if you need any help at all.